Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome once again to all of you to the physics classes. Dear students, we were talking about numerical sums in the case of work, energy and power. As of now, we have discussed still the topic called power, and after that we were talking about some of the numerical problem, maybe on power, maybe on kinetic energy, change in kinetic energy, work energy theorem or work, because some of the topics we have already covered. Now we were talking about the problem, so one of the problems we have written on the board. Okay, we are going to deal with this. Okay, so what it says, a raindrop of mass 1 gram is falling from a height 1 kilometer. See, the meaning is 1 kilometer height is there. 1 kilo means 1 into 10 to the power 3 meter, because we have to write down all the things in terms of SI units. Kilometer is a suffix we have used, no, kilo. So always 1 into 10 to the power 3. Kilo means 10 to the power 3. Kilometer, that is the height. Okay, next, what is the mass of that? Mass is nothing but mass of the raindrop is nothing but 1 gram. 1 gram means what? 1 kg means 1000 grams. 1 grams means, okay, because all the things we are going to tell in kg. Okay, that mass we are going to tell in terms of kg. 1 kg means 1000 grams, or 1 gram means how many kgs, that is divided by 1000. So it is nothing but 1 into 10 to the power minus 3 kg, right? Mass, because divided by 1000 goes to the numerator, 10 to the power minus 3 it becomes. Now the ground hits the ground with the speed of velocity. See, the final velocity it hits the ground is 50 meter per second. 50 meter per second. What is the work done by the gravitational force? What is the work done by the gravitational force? What is the work done by the gravitational force? It will always pulls that drop to the downward in the downward direction, right? Now object, or I can say the drop was at rest here. Okay, the drop was at rest here. No, now gravitational pull or gravitational force pulls it down so that it will get energy here or velocity here. Now what is the work done by the gravitational force? Work done by the gravitational force is nothing but force into displacement. Force is nothing but m into g, displacement is h. We can write down m is nothing but 1 into 10 to the power minus 3, g is nothing but, actually it is 9.8. For my convenience I am going to take it as 10 meter per second square into, what is the height? Height is nothing but 1 kilometer, so that is nothing but 1 into 10 to the power 3. 1 into 10 to the power 3. So 10 to the power 3 minus 3 cancels, so we are going to get 10 joules. That is the work done by the gravitational force. Now what we have to find out, what is the work done by the unknown resistive force? I am going to erase this so that I can write down the answers here. What is the work done by the unknown resistive force? What do you mean by resistive force? What is that unknown force of resistive force that we have to calculate, or that we have to see now? Okay, now see, the raindrop is falling means air will be there, air particles will be there. So the drop was at rest, it is going to fall, increases velocity, it is going to fall, increases velocity, it is going to fall, increases velocity, increases. Okay, when it goes on going to increases, the air particle is going to apply the opposite force to that. Okay, so what happens? Velocity increases and reaches a maximum value. After that it becomes constant. Why? Okay, why? Because that resistive force, that is nothing but, okay, if I can show in the diagrams, in this way we can talk. So raindrop mg is this force, this resistive force. Because when this velocity goes on increases, this resistive force is goes on increases. Okay, so at fine movement that mg and resistive force becomes equal. So one force is in one direction, another force is another one direction, means what happens? The force on the object is zero. The net force on the object is zero. That is, you are pulling that raindrop in the opposite direction, in this direction, that way. But raindrop does not stop, it moves. That is what Newton's third law, that is what Newton's first law says, right? Object is, in the uniform motion. Object may be at rest or object may be at uniform motion when the external force on that object is zero. Now the external force on the object is zero, but that is uniformly moving and is the ground with that maximum velocity, that is v 50 meter per second. Now we can calculate, we have to calculate what is the work done by the unknown force. Let's see what is the work done by the total work done. How we can calculate the total work done? We know that total work done is nothing but work done by the resistive force and work done by the gravitational force. Now we don't know that what is the resistive force is, so we can't calculate directly F into x in that way. Okay, that's why what we are going to do, we are going to consider that equation in such a way that work done by the resistive force will be equal to work done by the delta k minus work done by the gravitational force we are going to do. Okay, but resistive force we have to find out. This we know. What is delta k? Change in kinetic energy means final kinetic energy mvf square minus initial kinetic energy, right? But initial velocity was zero, right? Initial velocity was 0, so this term becomes 0. Final means half into m is nothing but 1 into 10 to the power minus 3 into vf whole square means 50 into 50 meter per second. So 50 into 50, it becomes 2500 into 10 to the power minus 3 divided by 2. Divided by 2, 10 to the power minus 3 goes here, no? Okay, so it becomes 10 to the power minus 1 because 2 0 it goes. So it is 125 into 10 to the power minus 1. So we are going to get that changes kinetic energy is 1.25 joules. 1.25 joules. No? Yes. Now what we have? This work done by the resistive force is equal to 1.25 minus 10. How much it is? 100 minus 125. No, that is nothing but minus how much? 1000 minus 125, 9 point, isn't it? 8.75. Okay, minus 8.75 joules. Why it is minus? Minus is because that resistive force does the opposite way. Opposite way it will do the work. No, force is opposite, but the displacement is in the opposite direction. So both are in the opposite direction, so that opposite force. Okay, this is what one of the numerical sum we have got. So it is very easy. Go to the concept. Once you will get the taste of dealing with these numerical sums, later you will going to enjoy all the numerical sums. So try hard and study. You can go for the numerical exercise questions also, and in different books exercise given. So there is a book called exemplar book also. You can refer that also for the different conceptual questions. Okay. So we have a one more problem. So that is nothing but which is based on variable force. Okay, now the variable force is given, that is F is equal to x plus 8 on a particle. Calculate the work done by the force during the displacement of the particle from x is equal to 1 meter to x is equal to 3 meter. X is equal to 1 meter to x is equal to 3 meter. You are going to apply the force on the object, that is variable, that is not constant. Now how you are going to find out? So we know that work done by the variable force is the integration of f of x dx, that is x initial to x final. Now x initial is x1, x it is 3, no, that is x plus 8 dx. Okay, so now it is given that work done which is equal to x plus 8 into dx. So you are going to integrate it. So multiply that x dx from 1 to 3 plus 8 dx from 1 to 3. So x dx, that is nothing but x square by 2. See, the integration of x to the power n which is equal to x to the power n plus 1 divided by n plus 1. So x to the power 1 is there, x to the power 1 plus 1 divided by 1 plus 1, from where to where? 1 to 3, plus 8 will be a constant, integration of dx is x, that is 1 to 3. So formula, this is the formula, integration of dx is x. Okay, so integration of dt is t, like that it is, that is a formula. I am going to erase this so that I can write down the answer here. Okay, now what we are going to get, there is nothing but 1 by 2, you will take it out. So upper limit minus lower limit, so 9 minus 1, okay, plus 8, upper limit minus lower limit, at the place of 3x you are going to put 3, at the place of x you are going to put 1, so that you are going to get 9 minus 1, it is 8, 8 by 2 it is 4, plus 3 minus 1 is 2, it is 16. So it becomes 20 joules is the work done by that variable force. This is the thing. Okay, so go through it once again. You will be having a problem with this, that is the integration. So you know, you have to know only 2 to 3 formulas. That is integration of dx is x, integration of x to the power n which is equal to x to the power n plus 1 divided by n plus 1 in this way, or integration of 8x dx. So x means dx will come, okay, okay, dx is nothing but 8 into 8, not 8 is k, it may be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever may be the number. Okay, whatever may be the number. So k into integration of x dx which is equal, it becomes same, that is x to the power 1 plus 1 divided by 1 plus 1, no. Okay, I can write down xn n plus 1 divided by n plus 1 into a k, no. So limit is there, means limit you have to apply, upper limit minus lower limit. So that is the application of the limit, how to apply that I told. Okay, so again in detail you are going to study about in mathematics also. Okay, okay, so again one more problem. A cyclist comes to a skidding stop in 10 meter. So cyclist is there, in 10 meter is going to stop, he applies the brakes we can say, so that is going to stop after 10 minutes, sorry 10 meter. During this process the force on the cycle due to the road is 200, in this way, no, 200 Newton, okay, 200 Newton. So we can say around horizontal, no, cycle force will be in this way, no, you are going to skid, you are going to give a frictional force, you are applying the brake, but still you are skidding and you are moving to the 10 meters. See, so road will be applying the force in this way, you will be applying the force in this way, the frictional force will be in this way, right? Okay, now due to the road is 200 Newton and is directly opposed the motion. How much work does the rod, how much work does the road do on the cycle? How much work? So that is nothing but work done, which is equal to F D or F dot D, isn't it? So work done is equal to F D cos theta. So F is how much? That is 200 Newton. That is force applied by the rod on the cycle, and D is 10 and theta is 180 degree, cos 180 degree, cos 180 degree. Now what you are going to get? Cos 180 degree means that is 2 into 10 to the power 3 minus 1, cos 180 means minus 1. Okay, so you are going to get work done which is equal to minus 2000 joules. So why it is negative? Because bicycle applies force in one direction, the road applies force in another direction. The next question is, how much work does the cycle do on the road? The cycle is going to apply the force right on the road. Okay, now what is the case? Work done, force into displacement into cos theta. Now force is there, that is Newton's third law, no? Equal and opposite force. Whatever the road applies the force on the bicycle, the same force is applied by the bicycle. But okay, what is angle? 180 degree. But what is displacement of the road? What is the displacement of the road? The displacement of the road is 0. The displacement of the road is 0. So that work done by the cycle on the road or bicycle on the road is 0, because there is no displacement. That is what you have studied in the case of Newton's third law. It says that equal and opposite force. There is equal and opposite force, but the work done by the equal and opposite forces not be same, need not be same all the time. Okay, need not be same. So not necessary equal and opposite, that work done is need not be same. So work done by the bicycle on the road is 0. So we have one more problem, that is a pump on the ground floor of a building pumps the water to fill a tank, okay, to fill a tank of volume 30 meter cube in 15 minutes. That is 15 minutes means 15 into 60 seconds, isn't it? 15 into 60, total that 1 minute means 60. So that is what you are going to get. It is 900 seconds. Okay, then if the tank is 40 meter above the ground, if the tank is 40 meter above the ground and efficiency of the pump is 30%, efficiency means eta you are going to write down. 30% means out of 100 it is 30, out of 100 it is 30 means 0.3. okay, then how much electrical power is consumed by the pump? How much electrical power is consumed by the pump? And they have asked you to take G is equal to 9.8. Now whatever the power you give, it will work only 30%. It will work only 30% of that. Okay, but it is told that in 15 minutes it has to lift the water and it has to fill that tank. Then how much power you have to give? But it only takes 30%, no? It only takes 30%, means 20 chocolates you have given or 10 chocolates you have given, it only takes 3 chocolates and 7 chocolate discarded. Again, but in 15 minutes it has to eat 30 chocolates. Now more and more chocolates you have to give, no? Because that 7 will be always lost each and every time, like that it is. Okay. Similar means efficiency itself like that. Efficiency means what? So 100 you have, but you can have only 3 chocolates. 100 chocolates are there, you can have only 30 chocolates, not more than that. That is efficiency, how efficient you are, like that. 100 out of 100 means, yeah, isn't it, like that. So now we are going to talk about, let's see what is the output power. What is the output power? Because it will take this much of water in 15 minutes means, what is the power actually it is doing? What is the work done it is doing? Power is nothing but work done by time, no? What is the work done it is going to do? M into G into H by T. Okay, M into D into H by, okay. So M means what? M means the mass. How much mass is going to fill? Mass is not given, isn't it? Mass is not given, but volume is given. We know that density is equal to mass by volume. So mass we want, mass is equal to density into volume. Density is nothing but 1000, volume is nothing but 30. So it is nothing but 3 into 10 to the power 4 kg of mass. So you can write down 3 into 10 to the power 4 into, for my convenience I am going to put 10, you have to put 8, 9.8, okay, into how much? 40 divided by 15 into 900, sorry, 15 into 60, that is 900. So how much? 4, 5, 6 into 10 to the power 6 divided by 9 into 10 to the power 2, you are going to get 12 by 9 into 10 to the power 2, 6 cancels 4. So 4 by 3, so that you are going to get 9 ones are 1.3 not 6, 306 into 10 to the power 4 watt power. Output power means what? That motor pump will take input power, it will do 30% work. For that 30% work, it needs this much power. But what you have to give? You have to give more, no, because it will work only 30%. It will work only 30%, no. So you have to give more power. Then what is that actually power you have to supply? Okay. Because see, that output power means it will only 3% it will work. You have to give 100% itself, no? 100% only you have to give. It will work only for 30%. That is what. Next, we know that to find out the input power, they have asked that how much electrical power is consumed by the pump. How much it will take consumed. This much power is needed. This is not consumed. This much power is needed to lift that water to fill the tank in 15 minutes. But how much I have to give? Because it will take only 30%, for 30% of the power it will take. So within 15 minutes it has to do means that much work. How much power I have to give? I know that efficiency is equal to power output divided by power input. Efficiency means input you are giving this much, but it will take only this much. Input you are giving this much, some value, but it only take that much of power, that much of work it will do. So that I can write down input power I want. So P naught divided by eta, that is the efficiency. P output is nothing but 1.306 into 10 to the power 4 divided by eta is how much? That is 30 out of 100, that is nothing but 0.3. So how much you are going to get? So divided by 0.3 means you are going to get 4.3. 4.3 into 10 to the power 4 into 10 to the power 4 watt, or else multiply by 10 so that you are going to get 43.6. okay, that is 4.36 into 10 to the power 3 watt. So you can write down 43.6 kilowatt. So here also you can write down, multiply means you are going to write down 13.06 kilowatt. You can write down, kilo means 10 to the power 3. If suppose it was 50%, if suppose it was 50%, if suppose it was 50%, then what? Double of that, no, double of that. Now it is only 40%, 30% of that, multiplied by that, divided by divided by 0.3. So 50% means you are going to get 26, like that, 26, because whatever you are going to give, half of that it will take. It is not even half, less than that half it is going to take. Half means 50%, 0.5. So that is the power it is going to say. So this is about today's problem. So again, normal numerical sums we have to study, other problems also we have to study. Okay, we will go through it in our next classes. So go through all the problems, once again go through it, that is input power and output power and all. So thank you very much for today's class. So we are going to discuss the remaining chapter in the next videos. Thank you very much.
Don't forget to like our video and subscribe our YouTube channel for all the updates.